Camille Kadoch with the Regulatory Systems Project, and our speakers today are Chris Neme of the Energy Futures Group and Paul Chernick of Resource Insight Incorporated. A few housekeeping notes before we begin. We're recording today's session for those who are unable to join us, or if you want to hear it again. With over 150 registrants, there's a lot of potential for background noise. As a result, we will have your phone lines muted. However, if you have questions, please type them into the question pane on your GoToWebinar control panel to the right of the slide deck. We will pause during the presentation for clarifying questions. For example, if you'd like clarification of one of the slides, or if you'd like further explanation of something Paul or Chris said, we will answer those in the course of the presentation. We ask that you hold all other questions for the Q&A session at the end of the webinar. We'd also like to note that we'll send out an email this week with links to the recording and the slide deck. I will now introduce our speakers in a bit more detail. We will hear from Chris Neme first. Chris is a co-founder and principal of the Energy Futures Group. He specializes in the design, implementation, and evaluation of energy efficiency policies and programs. In his 20-plus years in the energy efficiency industry, Chris has worked for regulators, other government agencies, advocates, and utilities in more than 25 different states, several Canadian provinces, and several European countries. His work addresses the robustness of energy savings goals, efficiency program performance metrics and related financial incentives, cost-effectiveness screening, efficiency potential studies, successful efficiency program design, the promotion of emerging efficiency technologies, and a variety of other topics. Chris has testified as an expert witness before regulatory commissions in 10 different jurisdictions in the U.S. and Canada, and has led several different training courses on the elements of best practice efficiency program design. He has also authored a number of papers and reports on a wide range of efficiency program and policy types. Next, you'll hear from Paul Chernick. Paul has been involved in utility planning and regulation since 1977, when he worked at the Massachusetts Attorney General and as a consultant. Since 1986, he has been president of Resource Insight Incorporated of Arlington, Massachusetts. He advises clients on a wide range of issues, including market price forecasts, planning and rate making for central supply, energy efficiency, renewable and distributed resources, and least cost compliance with environmental regulations, cost allocation and rate design, transmission and distribution planning, and evaluation of environmental externalities. To date, he has testified in approximately 300 regulatory and judicial proceedings. Paul has been involved in the estimation of DRIPE for the New England Regional Avoided Costs since 2007. In the course of this work, he has developed methods used for estimating electric energy DRIPE, capacity DRIPE, and natural gas DRIPE. He has also worked in this area in Pennsylvania, Maryland, and Illinois. So without further ado, I'm going to turn it over to Chris to begin our presentation.
Great, thank you, Camille. I'm going to just start by giving a quick overview of what the presentation is going to cover. I'm going to begin by providing a little bit of context for the study, why it was done, and the environment, the regulatory and legal environment related to energy efficiency in Illinois, which was the context for it. Then the bulk of the presentation will be the second piece here, where Paul is going to present how he approached the study and what results he found. And then I'm going to conclude with a few kind of summary points, both relating to some of the kind of key policy questions around DRIPE and the current status of the discussion around the topic in the state of Illinois. So you can move to the next slide, Deb. Oh, and one more. So by way of background, in Illinois, there have been electric efficiency programs for a number of years now. The utilities are in their 7th fiscal year currently of running these programs. Those programs were initiated through a statutory requirement that established an energy efficiency resource standard that had the utilities ramping up over time, increasing by roughly 0.2 percentage point in terms of the savings expressed as a percent of sales year over year and in the out years, even more than the 0.2 percentage point, to the point where they would get by the end of year 8 and beyond savings equal to 2% of annual system sales. However, that energy efficiency resource standard savings goal was also subject to a spending cap equal to roughly 2% of revenues, and it was made clear that if you hit the spending cap before you could achieve the savings target, that the spending cap became the controlling variable, and new savings targets would be set through a regulatory process consistent with what is possible within the spending cap. In practice, the utilities hit the spending cap in either year 4 or year 5, and savings under the efficiency resource standard as a result have ranged in recent years between about 0.6 and 1.0%, depending on the utility service territory and the year. Now, in addition to those energy efficiency resource standards, several years after those were adopted, there was another requirement put in place through a different law that would require the Illinois Power Agency to procure all cost-effective efficiency that the utilities were not capturing due to the spending cap from the residential and small business sector. We are now a few years into that process. Again, the effect of that requirement, and there's a complicated process by which those additional savings opportunities are identified, which we won't go into today. But the key point is that requirement effectively eliminated the spending cap for residential and small commercial customers, and essentially made cost-effectiveness screening the determinant of whether additional savings would be required or not. Next slide, please. So that brings us to kind of a quick overview of how cost-effectiveness screening has worked in Illinois and how it's defined. By statute, the state is supposed to be using the total resource cost test, the TRC. The statute makes clear that the TRC is defined as the sum of the utility's avoided costs, those that accrue to the system and the participants. It also says that in addition to that, for clarification purposes, that those avoided costs should include a value of the avoided cost of complying with likely future greenhouse gas regulations. And then in addition, it says that other quantifiable societal benefits should be included. It was within that context that NRDC, the Natural Resources Defense Council, expressed an interest in exploring whether price suppression effects or demand reduction induced price effects, DRIPE, which is the subject of this webinar, could be quantified and included in the test. And Paul and his firm were hired to do that analysis of what energy DRIPE on the electric side would look like in the state. Next slide. And I believe this is where, so we'll pause here for just if there's any clarifying questions. Camille, you can flag them. Otherwise, we can proceed on to Paul's discussion of the study and the results.
No clarifying questions yet, so we can proceed.
The floor is yours, Paul.
Okay, I think I'm unmuted now. So ready to move on to my slides? Okay, basically what I cover in this presentation is the basic idea that in competitive markets, lower demand means lower prices. I briefly describe my estimation of Illinois electric energy DRIPE for the restructured utilities in that state. And I discuss the consistency of DRIPE with the philosophy of TRC screening. Next slide. Okay, this is a sort of a standard Economics 101 graph of a supply curve slanting upward to the right, an initial demand curve, the red line, that is pushed down and back by the effective energy efficiency. You have lower load. That results in a new demand curve which crosses the supply curve at a lower price. And This is an illustration basically taken from a, for capacity price in an ISO. This was specifically illustrating the point for PJM, where there's an administratively determined demand curve with a slope. For energy prices, almost all the time, you have an essentially vertical demand curve. Next slide. Okay, so there are a couple of approaches for estimating the value of electric energy DRIPE. The first is to use a production cost model, change the load, and observe the change in the model estimated price. Those results tend to be very messy because the models have a lot of steps that can introduce small changes in the results as a result of essentially random changes in the way that the program operates. And it's hard to tell with relatively small load decrements of, say, 1% or 2%, whether the results that you're getting are really due to the reduced load or because the model is behaving peculiarly. The other approach, which I've used, is to do a regression of historical hourly prices as a function of loads. For Illinois, we had a little over 3 years of data. We split it into peak and off-peak. And to get rid of some of the inter-month variation in things like gas prices, available capacity, maintenance schedules, we normalized each month to both the load and the cost to a value of 100, and then did a regression using those normalized values. Next slide. Okay, this shows the 1 monthly scatter plot in the trend line for, this is for Commonwealth Edison for October 2012, and it's more or less representative of what you see. As load goes up, price goes up. Next slide. When we did our regression analysis looking at both MISO and PJM loads and the effect on prices in the Commonwealth Edison part of PJM and in the Illinois portion of MISO, we found roughly that a 1% load reduction causes a 2% price reduction. What wasn't as clear in this case was how large an area of load reduction was causing this effect. It clearly would be more than Illinois because Illinois is fairly well connected with its neighbors. It's unlikely to be anything nearly as large as all of MISO, which reaches up into North Dakota, and all of PJM, which goes all the way over to Delaware. And depending upon how you look at the regions that are relevant, Illinois might represent 25 or 50% of the load driving the change in Illinois price. So a 1% Illinois load reduction then would cause about a 0.5% to a 1%, I'm sorry, that's a typo, price reduction in Illinois. So 1% load reduction gives you maybe as much as a 1% price reduction, maybe as little as a 0.5%. Next slide. So what does that mean in terms of a price reduction? So if the market energy price is $50 a megawatt hour, reducing the price by 1%, the load by 1%, would reduce prices by, given the 0.5 to 1% range we were talking about before, somewhere between 25 cents and 50 cents a megawatt hour, which is not a stunning amount, but you're multiplying it over the entire remaining load that's being used by customers in Illinois. So it comes out to something like $25 or $50 per megawatt hour for Illinois customers. In addition, there may be some spillover to consumers in other parts of PJM, not so much in MISO because there's very little restructured load in MISO other than Illinois. Next slide. Those results that we got are typical of what you see in other studies. The Illinois Power Agency did a report on solar price effects, the covered solar price effects, and they got about $59 per megawatt hour benefit to Illinois customers from reduced net load from solar. The regional avoided cost analysis, the last one completed in 2013, estimated that a 1% load reduction regionally would cause something like a 1.2 or to 2.2% price reduction with a larger effect on peak. Back in 2009, NYSERDA did an analysis of load reductions from renewable energy, and they found about a 1.1% price reduction per 1% load reduction. And in 2009, PJM did an analysis that came up with something like between 1 and 3% price reduction for a 1% load reduction. Next slide. Now, not all of that price reduction flows through to customers. First of all, it only affects customers of restructured utilities. In many states, there are municipals or co-ops that are not restructured, or sometimes there are minor utilities that have not been restructured. There are, and there's also some short-term hedging because of the existing contracts. Customers have contracts with retail suppliers. The utilities have contracts which may go out a couple of years for whatever they call it in the particular state, standard offer service, standard supply. In some states, there are also municipal aggregators or governmental aggregators that similarly will have contracts for various lengths of time. So as long as you've got a contract supplying your load at a fixed price, the DRIPE benefits are not going to flow through to your customers. And then in some places, you also have long-term contracts which provide some hedging, either legacy contracts from before restructuring or utility-owned resources or post-restructuring projects for reliability or to encourage more renewable construction. Next slide. This slide briefly discusses how we estimated the short-term hedges for Illinois. Now, some of this is always a matter of judgment because while you can get very specific about what's known publicly in terms of what the utilities, or in this case the Illinois Power Agency, are doing in terms of hedging, you don't ever know what the people contracting with third-party marketers have in terms of hedges. But anyway, the estimate that we came up with was about 60% hedged, and only 40% of the benefit goes through in the first year, rising to 80% by the third year, and basically all of it after that. Next slide. Well, that's at the front end of the effect in the first couple of years. Over time, you'd expect a couple of market responses to the lower prices. First of all, customers are going to use somewhat more electricity, and that's going to result in somewhat higher load, and that counteracts the price effect of your lower usage from the energy efficiency in the first place. there are also pressures on the power plant fleet. Some plants that are right at the margin may get tipped over by the lower energy prices into retirement and therefore no longer be contributing to lowering the price in the hours where they're economic to run. Capacity additions may be delayed depending upon the situation. Upgrades, maintenance, various other factors that would affect the output of or the efficiency of existing plants may be deferred. And where you do add capacity, if market prices are lower, you're more likely to go for peakers rather than spending the extra money for a combined cycle, for example. Next slide. So combining those two effects and recognizing there's a lot of judgment involved, this is sort of the range of DRIPE, energy DRIPE effects that I estimated for Illinois by year. It starts low because of the hedging. It rises as the hedge dies out and starts to fall off as the longer-term price responses kick in. Next slide. And for the Illinois example, here are just the levelized values of DRIPE as a fraction of the energy price for various periods. It's highest in the short term, the relatively short term, when you pick up the years with the greatest DRIPE primarily, and as you look at longer and longer periods, it decreases. Next slide. Chris will be talking about this a little bit, but I just briefly cover a couple of points. DRIPE looks a lot like a TRC benefit. In many jurisdictions, legislation mentions price reduction as a goal of DSM, although legislation can be sometimes hard to interpret as to the intention of the legislature. DRIPE is also consistent with the way that we measure costs for, say, energy efficiency or distribution, excuse me, for distribution costs. Payments to contractors and suppliers, including their profits, are treated as costs. So to the extent that we're decreasing the profit to generators, that's just like decreasing the profit to a contractor or a supplier by negotiating better price, and that's generally viewed as being a benefit to the system. And finally, we take the same kind of approach in power procurement when the utilities are getting their basic service or standard service. Lower prices are better. The profits to the suppliers or the marketers are treated as costs. They're not included as part of the system for which we're trying to minimize costs, maximize net benefits. Next slide. DRIPE is not universally recognized in the restructured states, but it is widely accepted. By my count, 7 of the 12 restructured jurisdictions include DRIPE in some form. Connecticut and Rhode Island recognize DRIPE not just in the state, but for their entire ISO, in that case New England. Maryland and Massachusetts recognize in-state effects. DC, Delaware, and Maine also say that they use DRIPE, but I haven't gotten into the details enough to figure out exactly how they do that. DRIPE-like effects are also included in evaluating renewables in many of those states, and also in New York, Ohio, Illinois, and even in Michigan, which is only 10% restructured. So for most customers, it doesn't make any difference. The market prices don't flow through to them. DRIPE effects, or DRIPE-like effects, I guess, were the basis for generation contracts in Maryland and New Jersey, which the courts were not happy with. And so of all the restructured states, I haven't, the ones that I haven't found any reference they're using DRIPE are Pennsylvania, Texas, and New Hampshire. And Vermont, which is still vertically integrated, includes 50% of the RTO DRIPE in their analysis of energy efficiency benefits. Next slide. There's a map showing those results. You'll notice that Texas does not fit on the same map as Rhode Island or Massachusetts. I think there's a little, both the geographic and a political discrepancy there in getting them all together. There are a lot of green states, although they tend to be small, and a lot of places where, other places where it's, DRIPE is reflected for renewables or other purposes. Next slide. So far we've just been talking about electric energy DRIPE. We don't have time to get into them today, but electric capacity DRIPE, the DRIPE effects on really continental natural gas supply costs, the effect on natural gas transportation basis, the net cost of getting gas into a particular region, which is very important for electric generators, which you're usually buying in the spot market, and then the effect of all those gas price effects on electric price. Those have all been dealt with in various jurisdictions, primarily in New England. Next slide. And we're ready for questions.
All right, Paul, we have two clarifying questions on slide 17, and in just a moment, Deb is going to pull this up. And I have one more question that I'm actually going to hold for the general Q&A session. So on slide 17, where does the 99 megawatt hour number come from?
I think maybe you're talking about slide 16.
Maybe it was from this. Maybe that was 16.
Okay. So for every, with a 1% load reduction, for every one avoided megawatt hour, there are 99 megawatt hours that are still being consumed that are subject to the price effect. So hence the 99.
Got it. Thanks. And then moving back to slide 17, are all these analyses produced using regression analysis like the Illinois study?
I'm pretty sure that the two at the bottom use production cost modeling. I'm not sure what IPA did, and the New England study used regression analysis.
All right. Thanks, Paul. I think we can move on.
Okay, I think this is where I jump back in. So Deb, you can move to the next slide. There you go. So I wanted to touch base just as we conclude the presentation just on a couple of items. The first one was that I want to acknowledge that there is in various circles, including in Illinois, kind of a debate among different folks. Smart people don't always agree on this question about whether DRIPE is a benefit that should be included in cost-effectiveness screening, or whether it is just a transfer of wealth from generators to consumers, because lower prices to generators result in lower payments to generators, result in lower prices to consumers. And the argument in some circles has been, if it's just transferring wealth rather than producing an overall net reduction in societal costs, then it may not be a benefit to be included in screening. So that's a debate that's that I've been part of in several different jurisdictions and in a bunch of private conversations as well. And I just wanted to touch on a couple of issues or frame that debate a little bit for the benefit of the folks on the webinar. As we've discussed this, it seems to me, and I think to Paul and perhaps to many others as well, that your answer to this question about whether DRIPE, whether price suppression effects are a benefit or not, depends on whose impacts policymakers care about or should care about. If the concern, and think about it this way, if you're to draw a kind of a circle or put a bubble around the folks in the entities in the economy that you care about, if it's just the utility or the utility and its customers, and generators are outside of that bubble, if you will, then this would be a benefit. If you're truly drawing the circle around the entire globe so that you care really only about what the impacts are in net terms across the entire globe, where the globe would therefore include generators, then one can see how the rationale to the argument that this is a transfer of wealth rather than a benefit. Now that brings us, I want to take that kind of summary conclusion to kind of the next step related to the different cost effectiveness tests that are commonly used across the country to determine whether efficiency programs and portfolios are cost effective or not. That kind of way of thinking of things would suggest that DRIPE or price suppression effects are benefits under the utility cost test, because under the utility cost test we're simply drawing the circle around the cost that the utility incurs and that the consumers of utilities, the ratepayers of utilities, ultimately see. If we're thinking about the TRC, the total resource cost test, and I think conceptually the TRC is meant to essentially be the utility plus the benefits, or plus the participants of the efficiency programs. That's the principal difference between the TRC and the utility cost test, is that it includes not just the utility costs and benefits, but any additional costs and benefits that efficiency program participants realize. The generators are still outside that circle under the TRC. So it would seem to suggest that this would be a benefit under that cost effectiveness test. If you were to a jurisdiction where you're using the societal cost test and truly drawing your circle around everybody across the globe and including all of the costs and benefits of all types to society, then DRIPE may not be a benefit in that context. And again, it really begs the question: where are we drawing the boundaries here? And perhaps we can move on to the next slide, because this might hit this home a little bit harder for the TRC. So what we've got here on the slide is an excerpt from a report done for RAP a few years ago by Tim Wolf of Synapse Energy Economics that summarizes the 5 different perspectives, the 5 typical cost effectiveness tests that are used across the country in various forms relies on. And the total resource cost test, the second one down, is the one that's circled. And here it just kind of underscores that the question that the TRC is meant to address is, will utility costs and program participant costs decrease in aggregate? So again, it's drawing the bubble around the utility plus the participants. And I think it's at least to me fairly clear that the generators are not part of that bubble, if you will. If you moved one step up to the societal test, again, that may be a different question. Next slide. So lastly, I just want to catch folks up on, this was a study done looking at the issue, or they're trying to quantify the magnitude of energy DRIPE, and electric energy DRIPE in Illinois. So catch you up on where the discussions, now that the study's been done, are with respect to this topic in Illinois. And I'll just start by noting that this past fall, an argument was made in a case related to the Illinois Power Agency's procurement of that additional residential and small business efficiency, that DRIPE should have been used in screening of programs to determine which of those programs the IPA was going to procure. After a kind of an abbreviated process, because abbreviated not in a negative way, but just the process that the Commission undergoes to review and approve the IPA's proposed procurement just runs a few months. But where there was a lot of back and forth in that proceeding, the Commission ordered that while there were a lot of interesting issues raised in the case, it was a challenging case, in part because of the time frame and in part because of perhaps some limitations on the parties that were involved in that case. The Commission elected not to make a determination on whether DRIPE was a benefit or not, and what the magnitude of it would be if it was, and instead ordered that the stakeholder process that currently exists in Illinois to consider different energy efficiency issues be leveraged with a series of workshops to try to sort this out among the different parties, and then to report back to the Commission. There was a day-long workshop focused on just this issue of DRIPE in January. I think it's fair to say that there was some disagreements during that conversation, during that workshop, that has not yet sorted itself out. And my take is that the key issues that are still under discussion are first of all the question of whether this is a benefit or a transfer of wealth in the context of screening, cost-effective screening for Illinois, and then secondly, what is the duration of what is a reasonable set of assumptions about the duration of this effect? How quickly would the market react, and would the DRIPE effect fizzle out? I just want to conclude by saying that this workshop process is not yet complete. We did have a full day of discussion, but there is more still to come, and time will tell whether the different parties around the table could reach an agreement on this issue or not. So with that, I think we conclude our presentation.
All right, thank you, Paul and Chris. And just so everybody knows, we have about 15-20 minutes here for questions. We have a few questions here, but not a ton, so please send in some more questions as they occur to you. Chris, going back to slide 29, a question came in regarding whether or not it's a transfer of wealth or a benefit. The question is, can it be both? If the price effect is a benefit, but the reduced avoided emissions produced by load reduction is a transfer of wealth, since it is a societal benefit. So the question is, can it be both a wealth transfer and a benefit?
Well, in some ways, I think it's a public policy. It's a public policy question. Regulators or policymakers could, in fact, determine that what they care about are the benefits that accrue principally to ratepayers, and that even though it may be under a pure societal viewpoint a transfer of wealth from generators to ratepayers, from their perspective, their principal concern is around ratepayers, and therefore it is a benefit that could or should be included. I think in many respects that's what it boils down to. What are whose impacts are the impacts of greatest concern to the policymakers? Paul, do you want to add anything to that?
Yeah, I would say that the question is do you view it as a transfer within the quote society unquote that you're concerned about? And if you do, then it wouldn't make much sense to call it a benefit, because if you said that the generators are somebody that you care about just as much as you care about ratepayers, then taking money away from them and giving it to the ratepayers is a wash. But you can certainly say, yes, it's a transfer, but it's a transfer from of a benefit from outside of our bubble into our bubble, and therefore it's part of our test, even though we know we're moving wealth around.
Okay, we have a few more questions coming in. I would like to make a note. One request had come in for the citations of the studies reported in slide 17, and we will provide those when we email the links to the webinar later this week. So those will be provided. The next question is, how is the duration of DRIPE estimated?
This is Paul. The issue there depends on whether you're looking at a system with a lot of excess capacity of basically the same type, or one where a small change in prices may result in the retirement of a whole class of generators, such as your coal plants, rapidly driving up the energy prices. And basically you have to look at it in each situation and make, sort of tell a story that makes sense about what you think might happen. And like all forecasts, it's subject to discrepancy with reality. We've seen a lot of examples over the years of generators that respond very slowly to what look like unfavorable price signals, but sometimes they can respond quite quickly. So, trying to figure out what kind of situation you're facing in a particular market really is a judgment call.
Okay, the next question is, when you say that only customers of restructured utilities and the like would benefit from DRIPE, is that just because the vertically integrated utility retail prices aren't directly connected to market prices? It seems like a vertically integrated utility in MISO should still get some benefit because all the load is technically has to buy its power in the market.
Well, in that case, if you reduce by $1 a megawatt hour the price that the integrated utility is getting for all of the power it sells into MISO, and reduce by $1 a megawatt hour all of the power it buys from MISO for its customers, then assuming that the utility is generating about the right amount of energy, is a very small net buyer or seller, then there's not really going to be any net benefit. Now, if you're a vertically integrated utility, but in fact you're buying half of your power from the market and generating a relatively small amount for yourself, then it may be that you can get some benefits.
A follow-on question to that one was, do you just expect that the price suppression benefit would wash out between the price load pays and the revenue generation we receive when you're talking about vertically integrated utilities?
Yes, as I've said, it would, you could have a situation where you have either a very different pattern of generation and consumption or very different amounts where that wouldn't really be true. But where the utility is producing about the same amount of energy that it's delivering to its customers, the two would be roughly a wash.
Okay, so getting back to the transfer of wealth question, we've had a request to elaborate on how it is a transfer of wealth under the societal cost test.
Okay, I'll start with this one. The idea behind the transfer of wealth argument is that, to use Paul's term or analogy, a bubble. If you're drawing a bubble around a group of market actors that include both consumers and generators. What's happening when you for example, eliminate the need to build a new power line is that the consumers benefit from that because they're within that bubble, because there is no the society doesn't have to make an investment, a capital investment, to produce something. In the context of DRIPE, when the bubble includes both generators and consumers, there's no change in what society is actually producing in terms of a product. What's changed is how much money are in the pockets of the generators versus in the pockets of consumers. And the price suppression effects, essentially, because they lower the market clearing price of energy, mean that for the remaining generation, generators get less money. The generators that are still clearing the market get less money, and consumers get more money. Paul, do you want to add anything to that?
Yeah, basically, if there are a lot of situations in which things that a regulator could do would, say, increase rates for and bills for residential customers and decrease them for industrial customers, or vice versa. And while some of those are done intentionally on the grounds of equity, I don't know of any regulator that would say, oh, well, we're lowering residential rates, but all of those dollars are going to be paid by the industrial customers, but we'll ignore that because we only care about the residential. They view the industrial customers and the residential customers as being equally important for resource planning decisions anyway. And in the same way, if you extend that bubble further and say, okay, and we're also going to include the generators and our suppliers of other services, then you don't care how much they're getting. A dollar going to them is the same as a dollar going to the ratepayers.
Okay, the next question is, if a vertically integrated utility purchases some of its energy through bilateral trading hubs, such as the Mid-Sea and the Pacific Northwest, then can a DRIPE effect be expected to occur there too?
It could, if the utility is a net purchaser, and it would have to be a significant net purchaser to make it worth doing the calculations and actually looking at that kind of analysis. But if, for example, it's vertically integrated, but it's buying all of its or 80% of its power through contracts from everywhere from hourly to a couple of years at a time through a market hub, then essentially it's looking a lot more like a restructured utility, and you could include a lot of DRIPE for that situation.
Okay, another question is, do you think that the DRIPE effect is a net job generator, since there are more jobs associated with the respending of electricity bills than from electricity generation?
Well, we haven't done an analysis to attempt to quantify that. Intuitively, that sounds right, and actually, I would also say that that's over and above what has been studied in a variety of jurisdictions, over and above other job benefits associated, net job benefits associated with efficiency, because it's DRIPE is only one of the many benefits of efficiency. The other benefits are substantial in terms of putting net dollars in consumers' pockets, typically, which also reverberate through the economy. Not to mention the fact that in general, my sense from the studies I've seen is that efficiency investments tend to be more labor-intensive than generation is. But again, with respect to DRIPE alone, I intuitively understand the argument, but I haven't seen anyone actually try to quantify that. I don't know if you have, Paul.
No, I haven't, and again, that would also depend on where you are and what the effect is. If all you're doing is burning less coal and gas in your power plants and running them less and being able to and the price is being set at by more efficient units more of the time, and so market prices are lower, it may have no effect on employment at all, at least not in the in your local area. It might have some effect on coal miners far away or gas drilling employment in North Dakota, but it would be pretty tenuous effect. On the other hand, if you're deferring construction of resources that require a lot of manpower to build and operate, there may be a bigger employment effect on that side. But I don't know if anybody who's tried to relate the employment effect to DRIPE specifically.
Another question is, has the discussion of benefit or transfer of wealth under the societal cost test included health or environmental costs that are avoided due to reduced generation?
I'm sorry, Camille, could you say that again?
Yep. Has the discussion of benefit or transfer of wealth under the societal cost test included health or environmental costs that are avoided due to reduced generation?
I would say that really is an even more separate topic than the employment effects. And certainly there are health benefits from reducing generation, especially by fossil fuels, but those really ought to be separately estimated and added in as a health benefit for whatever area you're concerned about. And some regulators have decided that they're concerned about downwind consumers of air, whom they're not concerned about as consumers of electricity because they're outside their jurisdiction, but they do feel some moral responsibility to their neighboring states or even to the world environment.
Yeah, and I would just add that I see this as reduced environmental emissions, pollutant emissions that cause health effects as essentially another cost associated with power generation, or I should say the emissions that lead to health effects from generation of using fossil fuels, or for that matter, even if it's something else, are a cost of the generation, and the fact that efficiency causes less pollution and therefore less of those health effects is quite directly a benefit. I don't see how the transfer of wealth argument would apply in that context. But the other thing I would say, not directly related to that question though, is that again, if you're going to accept the transfer of wealth argument and that DRIPE is not a benefit under the societal cost test because you're looking at society writ large, the globe, then you really do, the analog to that argument is if you're going to take that perspective, then you really do need to try to quantify all of those other societal benefits, whether they're in your jurisdiction, 3 states over, or even across an ocean or two, because you're drawing the boundary quite broadly at that point. So that they may cause you to exclude price suppression effects, but it should force you at the same time to look very broadly at the value of those other kind of wide-ranging health and environmental benefits.
Okay, it looks like one more question before we do a quick recap here. Paul or Chris, can you recommend any studies that have looked at natural gas DRIPE? And perhaps we can also email this later as well. But any off the top of your head?
Yes, the NYSERDA did some work back in 2006 or so, and we've done some in New England as well. And yeah, we can add those citations to the email that goes out. Maybe we can even add them to the final version of the slides if people want them.
All right, thanks. Chris, back to you.
Okay, thanks, Camille. So I just wanted to conclude with the kind of revisitation from our perspective of some of the key points that we discussed today. The first is that there are price suppression effects in restructured states, places where there's wholesale competition in the energy markets that are measurable, we believe. In Illinois, we found, depending on the length of time you're looking out over, but let's take a typical efficiency measure with a 10-year life, that the value of those price suppression effects would be equal to somewhere in the 25 to 50% of the avoided energy cost value. We haven't done the analysis beyond electric energy, but there are jurisdictions that have quantified benefits for price suppression effects in capacity and natural gas, as Paul just noted. There are certainly raging debates around this topic, particularly related to the question of whether it is truly a benefit that ought to be included in cost-effectiveness screening or whether it's a transfer of wealth. I think the key point there is that the answer really depends on how policymakers view their role. Which parties are they looking out for when they make resource investment decisions? If it is principally the utility and its ratepayers, that would be either under the utility cost test or the TRC, for example, then it's hard to see why price suppression effects wouldn't be considered. Conceivably, under a societal test where you are truly looking at everybody and you include generators under your bubble, so to speak, then one could rationalize the argument that, or accept the argument that is a transfer of wealth rather than a net benefit. But going down that, taking that perspective also requires that you consider the whole range of societal benefits to be part of your decision-making process as well. And I guess the last point I'd make is that this is I don't believe that there were any states 7, 8, 9 years ago that were including DRIPE. This is in their screening. This is something that's been looked at particularly closely in the last half a dozen years or so. And as Paul noted in his slides, the majority of the jurisdictions, well, certainly not all of them, the majority of the jurisdictions that are restructured are now including consideration of DRIPE in their determination of what efficiency programs are cost-effective or not. So I think that those are kind of the high points. And again, as Camille noted, I think we'll be doing some follow-up with some of the information that's requested here to provide folks some additional information.
We certainly will. We will be sending out a link to the slide deck and the recordings later this week, and it will contain the citations that were asked for and some of the follow-on information. I wanted to thank you all for your attention, and also to thank Chris and Paul for their expertise and presentation today. If anybody has burning questions that were not answered during the presentation or that occur to you later, Paul and Chris have offered to respond to them via email, and their email addresses can be found on the last slide in the slide deck. So with that, thank you all for your attention, and I hope you have a good day.